Let's try number 20. Number 20, let's see. We got a disjunction we're trying to get. And remember, there's a few ways to get a disjunction. We've expanded from just our implication rules. We had addition and constructive dilemma that would help us get disjunction. Now we got some more options. Of course, we can do association, but that's not really going to help because we're trying to get something with two atomic statements. Commutation, well, that'd be great if we just had these on flipped sides, but that's not what we got. De Morgan's, that really just works when negations are involved. So I don't know how much that is going to help us. So even though we have new ways of getting disjunctions, it doesn't look like those are going to help us directly to get E or F. So maybe we got to go back to our implication rules to get what we need. Of course, addition. If we could just get E by itself, that works. Or F by itself. Maybe to get E, if we just got B, but I don't see how to get B by itself or F by itself. Well, we had this. So notice that there's no like single letters atomic statements all by themselves as a premise. They're all like part of a compound statement there. So maybe addition isn't the way. What about constructive dilemma? Do we have that kind of set up to get in our rule R or Z? We need conditionals that lead to those things. And in fact, if you look at 1 and 3, we do have conditionals that lead to both sides, right? So that's nice. We actually have 2 of the 3 types of premises we would need to do constructive dilemma. What else would we need? We need something matching the P or S disjunction. So what would that be? Well, that would be the B on the left side of a disjunction, and then from F on the right side we need this, D or C. So this is a disjunction, right? It's complicated. The left side's nice and simple, but the right side is something in parentheses. Just like on the rule, we have P on the left, we have B, and on the rule we have S. On our example, we have D or C replacing the S. So a compound statement replacing just the S. So what do we do now? If we could get this disjunction, we could do constructive dilemma. So can we get this disjunction? Well, we're pretty close in 2. We've got all the ingredients. We've got B, C, and D. But we need to get B, and then the D and C, or the D or C needs to be reversed order. So a couple things going on there. First, let's go ahead and just switch C and D using what? Association? No, not association. That's commutation. So, but instead of looking at the wish list, this is what we have to work with. So I said that, but really we need to probably do association first, actually. We can't switch C and D in 2 yet because commutation only works when the 2 things we're switching are on either side of a operator like an or an and. But here we have a parentheses in the way, so we can't use commutation first on 2. We got to use association first. So let's do that. We'll take line 2 and use association on it. So that means, well, instead of B or C being associated, we'll associate C or D. So now it becomes this. And that's getting closer to what's on our wish list. Now all we got to do is switch the C and D. And we got to make sure to remember to annotate. So that's to association. And when we flip the C and D, that's going to be D or C from for commutation. The D commutes over and the C commutes over. So now we have our disjunction we wanted, and we can go ahead and do constructed dilemma. So 5 with the conditional in 1 and the conditional in 3. Constructive dilemma, that's going to give us E or F. Perfect. So there you go. That one was a little complicated, and you had to make sure you do the order correctly, right? So you had to do association first and then do commutation. If you did commutation first on 2, you could only switch the B or C part, right? Just switch those. But what you really need to switch is the C with the D. But you got to get this parentheses out of the way first. Awesome.